All right, we are here to do a walkthrough of practice quiz number 2 for LT number 5 on triangles. Let's start with standard 5.1. Use the triangle sum theorem. What does that say? The key here is all the angles in a triangle always add up to 180 degrees. That's your key. So here we've got 3 angles, and what do we know they do? They all add up to 180. So they add up 3 angles. X plus 43 plus 26. Those 3 numbers, x is just a number, must add up to 180. Let's combine those two. To get 43 plus 26 is 69. So x plus 69 equals 180. We want to find the difference between 69 and 180 because that's got to be what x is. So we subtract 69 from both sides. And 180 minus 69 is 111. So x must equal 111 degrees. All right, on the next one, we've got 3 things here. Again, they add up to 180. What are our 3 angles? The first angle is 7x plus 3 plus 50 plus 85. All of our pieces together must add up to 180. First step, let's combine all our numbers. So 3, 50, and 85. Keep the 7x there. 3 plus 50 plus 85 is 138 equals 180. Just like here, whatever this number is, 7 times this number, plus 138 equals 180. We need to find the difference. Take away 138 from both sides. That cancels. And you get 7x equals 42. Now, 7 times a number equals 42. So how many times does 7 go into 42? To do that, we divide. Divide both sides by 7 to get x equals 6. So x equals 6. All right, that is standard 5.1. Again, the key, add everything up to equal 180. Let's move on to golden standard 5.2. Now, this is using the Pythagorean theorem. What I might write here is I might write this right next to it. Leg squared plus leg squared equals hypotenuse squared. All right, I might start by doing that. So that way I don't have to remember as I'm doing it. First step, identify your hypotenuse. Remember, the hypotenuse is across the triangle. So that side is my hypotenuse, meaning the 2 sides that touch the right angle are the legs. Leg, leg, hypotenuse. So in this case, we're solving for that leg right there. We are solving for a leg. So we know that x squared, leg squared, plus leg squared, the other leg 14, equals my hypotenuse squared, which is 20. So x squared, 14 times 14, this little squared means times itself. 14 times 14 is 196, and that all equals 400. So some number squared plus 196 equals 400. So we need to figure out the difference. Subtract 196 from both sides. When we do that, those cancel. X squared equals 204. Now, I don't want x squared, I just want x. There's no squared there. So how do I undo a squared? Square root both sides. What number times itself equals 204? Use a calculator, okay? Use a calculator. It turns out, in this case, x equals 14.28. Now, you're going to round to 28, okay? So make sure you're rounding correctly. So x equals 14.28. So you can see a little bit. All right, let's look at the other one. First step again, identify your hypotenuse. Here's the right angle. Go across the triangle. So that means x is our hypotenuse, and these 2 sides are legs. Leg, leg, hypotenuse. So let's set up our Pythagorean theorem. Leg squared, 10 squared, plus leg squared, 4 squared, equals x squared, our hypotenuse. 10 squared plus 4 squared equals x squared. 10 squared, 10 times 10 is 100. 4 squared, 4 times 4 is 16, and that all equals x squared. 100 plus 16, add those together, is 116, equals x squared. Again, how do I undo a squared? How do I get rid? I don't want x squared, I just want x. Find the square root. Take the square root of both sides. Use your calculator. This rounds out to be 10.77 equals x. Now, how do I know if I'm correct? Well, the most important part here, 10, 4, 10.77. Which number must be the biggest number? The hypotenuse. If my hypotenuse, my answer I get, is not bigger than both legs, it'd be incorrect. Same on this side. If the answer I got for my leg was bigger than the hypotenuse, I'd want to check my work. All right, that's Golden Standard 4.2. Let's move on to Golden Standard 5.3. All right, so for 5.3, 2 parts. Part number 1, determine the area of the triangle. So here, I might write down my formula, base times height divided by 2. So let's identify our base and height. We got 3 choices, 20, 34, and 28 for our base. Well, the height and the base are perpendicular. Where do you see 2 segments that are perpendicular? I see these 2 right here. So I see this one is perpendicular to this one. Therefore, 28 must be my base, 19 must be my height. So to find my area, I do 28 times 19, and I'm going to divide that by 2. 28 times 19 is 532. 532 divided by 2 equals 266. Our units here are just units squared. All right, now determine the area and perimeter of the figure below. Combining a few things. Our goal, we want to, personally, my strategy, my favorite, is to cut it up into rectangles and right triangle. You may prefer to make a bigger shape and then subtract. Either way works. First step, let's see what we know. 9, 15, 13, 13, 27. Okay, I got a right triangle there. That feels good. I like that. I don't like this trapezoidal shape over here. I'd rather make that into a rectangle and a right triangle. So I'm going to draw a line right there. Now, what do I know? I see this 27 here. It doesn't really help me because I know this is 9, 13. Okay, so this is 13 right here. Well, if that's 9 and that's 13, and the whole distance is 27, what's left for over here? 27 minus 13 minus 9 leaves me with 5. So I'm going to cross off this 27. I don't need it anymore. I've split the 27 into 5, 13, and 9. So I don't want to get confused by that. So do I have everything I need to find the area of this triangle? I have a base. I don't have the height. Rectangle, I have the bases, no height. This triangle, I have the base, not the height. Clearly, I need to find this height. How do I find the height? Look at this right triangle that we have here. This right triangle looks like this. If I label this side as X, 15, and 9. Sorry, that's poorly drawn. So what am I solving for? Just like we just did on the other side. 15 is my hypotenuse. So I am solving the Pythagorean theorem. 15 squared hypotenuse equals leg squared plus leg squared. Let's solve this. 15 squared is 225 equals x squared plus 81. Subtract 81 from both sides, find the difference. I'm going to get 144 equals x squared. Square root both sides, and I'm going to get x equals 12. So where does this 12 show up in my figure? It's the height of my right triangle, so it must be that distance right there. If it's that one, that means it is also that one. So those 2 heights are 12. All right, let's see. Do I have everything I need to find my area? Well, I have 3 shapes that I've created. I've got one right triangle, height of 12, base of 5. I've got a rectangle, base of 13, height of 12. And I've got another right triangle, base of 9, height of 12. Great, that's everything I need. 5 times 12 divided by 2 is 30. 13 times 12 is 156. 12 times 9 divided by 2 is 54. Add those 3 together, and you are going to get 240 units squared. Now, that's our area. Our perimeter is the distance around. So what I like to do is start here, 13. So I'm going to do 13 plus, and I really just circle it, and I draw a line until I hit my next number. 15, go around the shape. Oh, hit a 9. Now it's okay the 9's written inside the shape because it describes this side. We would not include this 12 because it's describing this segment, which is inside the shape. We stay around the outside. Now I hit 13. And I keep going. Now I hit 5. And you see why I crossed off the 27 so I don't double count it. Keep going. I have one more number, plus 13. And look at that. Now I can see I already counted that 13, so I don't double count it. So if I add these all up, 13 plus 15 plus 9 plus 13 plus 5 plus 13, I should get 68 units. All right, that is Golden Standard 5.3. Let's move down to Standard 5.4. Now, these look complicated, but really what's going on here is you just need to use your understanding of triangles, triangle area, and Pythagorean to pull them apart, to solve for what you can. Ultimately, it looks like our goal is to figure out the length of that segment right there. There are no numbers anywhere in that triangle, so I have to work my way there. All right, let's figure out what we want to do first. I see that these three sides are congruent. So if I can figure out this side, I know what these two are. Well, what shape do we see here? If I can figure out this side, right, with the congruent mark, I could figure out the others. But look at this shape right here. I see that's a right triangle. I can work with a right triangle. So if I label this as, let's label this side as y right there. That way I don't reuse x. Well, that's the hypotenuse of this right triangle. So I could say 12 squared plus 16 squared equals y squared. 12 squared is 144. 16 squared is 256. That equals y squared. Again, y is just a placeholder. 144 plus 256 is 400. That equals y squared. Last step, square root both sides. And you're going to get 20 equals y. So this distance right here is 20. So if we know that's 20, great. Now we know this side's 20 and this side's 20 because of those congruent marks. Unfortunately, that's not quite enough yet. Because if you look at it, I don't know anything about the base here. I only have this side of this triangle with the x in it. But if I could figure out this base right here, then I would have enough to pull it apart. Well, I see that this is also a right triangle right here. I'm going to color it in pink. So it goes like this, then like over here, and then up here, this big one right here. If I could figure out the hypotenuse of this big triangle, I could take away 20, and that would tell me what that distance is from there to there. All right, well, let's do Pythagorean theorem again. So we're going to say, this time, we will label this part, we'll call it z this time. All right, we'll call it z. So we'll say leg squared, 14 squared, plus leg squared equals hypotenuse squared, z squared. Again, z is just a placeholder. 14 squared is 196. 48 squared is 2,304 equals z squared. Add those two together, you get 2,500. Last step, square root both sides. Turns out z is equal to 50. So this whole long length is 50. Therefore, what must this distance be from here to here? Well, if this whole distance is 50, and this part is 20, if that's 20, 20 plus what equals 50? This distance here must be 30. Okay, now I figured out some stuff about my x triangle. Let's draw it up here. So here's the triangle I'm working with. This distance is x. I know this is a right angle. I know this is 20, sorry. I know this side is 20. And I know this whole bottom length right here, this whole length is 30. Well, the isosceles triangle doesn't help me, but what kind of triangle does? A right triangle. So let me pull out this right triangle right here. This is what I'm looking for, this height. I know this distance is 20. Now this base down here, if 30 is the whole way across and the height cuts it in half, this must be 15 because it's half of 30. It's like 15 and 15. Look at that. Another right triangle. Let's use Pythagorean theorem to solve this. X squared, leg squared, plus our other leg squared, 15 squared, equals our hypotenuse of 20 squared. 15 squared is 225. 20 squared is 400. Subtract 225 from both sides. Can't find the difference there. X squared equals 175. Square root. Turns out our answer, x is equal to approximately 13.23 units. That is our final answer. For these 5.41s, it's all about just approaching it one step at a time, one step at a time. Figure out all the information you can. Hope that was helpful. Good luck with LT5.